everyone here, this is Eason Lee from Think Academy Singapore. As there are only 10 days before the NEMOS Round 1 test, we held this 10 days countdown section. Each day in these 10 days, we will choose a sections that will occur in a NEMOS Round 1 paper and choose 2 typical questions from the formal year's NEMOS paper. From these questions, I hope we can review the acknowledgement and find the method to solve such kind of problems. Okay, this is the first day we are talking about the angle calculations. Angle calculations will always have 2 questions in each year's paper, which will value about 5 points. So it is a very necessary acknowledgement point. To solve such kind of problems, we need to know maybe the sum of interior angles of a polygon, the exterior angle of a triangle, and the angles in a isosceles triangle, equilateral triangles, and right angle triangles. So I choose 2 questions both from the 2019 papers to help us find out how to solve 2 kinds of angle calculations. The first kind of calculations are held in a triangle, maybe a special triangle like these questions, isosceles triangles. In this part, it is always our first things to find the angles that are equal in the diagram. In isosceles triangles, the equal sides define the equal angles. For example, AB equals AC, so the angle B will be equal to angle C. For the same reason, AE equals AD, so the angle ADE will be equal to angle AED. This is the first thing we need to do. Then we can use our method to calculate it. For simple questions, maybe we can just use the 30 degrees and move forward and solve the problem easier. But in this more complex questions, sometimes we need some method in algebra. For example, for these questions, the question we should calculate the angle CDE, we can let the angle CDE be x. But if it's only the 30 degree and x, we cannot calculate all the other angles, so maybe another one is needed. The another one, maybe the angle B or angle C, maybe angle C here. Let it be A. The interesting thing is, in this kind of questions, we do not always need to solve all values of all unknown ones. Sometimes we just need A, B, C, maybe to represent an angle and value, but we do not need to solve it. Actually, we cannot solve it. During the process of calculations, it will naturally be cleaned. Let's find it out. For example, now we have the X and A here, so the angle AED is the exterior angle of the triangle CDE. So we have the AED equals to angle C plus angle CDE, which will be represented by A plus X. So the ADE equals to AED is A plus X as well, and B equals C is A as well. Now the only unknown angles will be this one, DAE, right? For DAE, we can use the interior angles in this triangle ADE. As the sum of interior angle of a triangle is 180 degrees, we can calculate DAE to be 180 minus 2 times A plus X. Right. On the other hand, when we look at the bigger triangle BAC here. So we will find BAC to be 180 degrees minus 2A here. Right. So when you compare with it, we have DAE added 30 will be BAC. So we have this formula as 180 minus 2A will equal to 180 minus 2 times A plus X, then plus the BAD, which is 30 degrees. Now, in this formula, we can clean the 180, the minus 2A's, which will becomes 2 times X equals to 30 degrees, where X should be 15 degrees. Now the question is solved. As I mentioned before, sometimes we can represent some unknown angles, with a code name such as A, B, or C, but we need not to solve it out. So in Chinese, we call it 设而不求. We represent it, but we do not need to solve its value. That's very important in such kind of questions. Okay, now let's move to the next type of questions, which will include polygon, or most normally regular polygons. For polygon problems, first of all, we should know for n-sided polygon, the sum of its interior angle will be 180 times n minus 2. This is the sum of its interior angles. For regular polygon, on the other hand, as all its interior angle is the same, we can calculate each of it to be, for example, this kind of questions, this is a 9-sided polygon. So each of interior angles such as A, B, C, H, I, right? For I, we should use HIA to be specific. It will equals to the sum of interior angles divided by 9, which is 140 degrees. This is how to calculate the interior angle of a regular polygon. And then we are moving to solve the problem, the angle GID here. If you want to calculate GID directly, it should be difficult, or maybe, in middle school, we can use the circle, use a circle to solve the problem easily. But now, we cannot solve it directly. But as we know, the angle HIA is 140 degrees. We can have alternative ways that we can just calculate HIG as well as AID here. Then we use the 140 minus these two angles to find our answers, right? So let's work it out. For HIG, it's easier one. For it's in non-isosceles triangles HIG here, right? In triangle HIG, we have HIG equals to HGI. And the IHG, the angle H, is 140 degrees. We can have this bottom angles to be 180 minus 140 and divided by 2, which is 20. The AID, on the other hand, will be more difficult. There are many ways to solve it, and the most easiest way is to use the symmetry of a regular polygons. We all know that each regular polygons is symmetry, and in this figure, it's kind of like this. So AID will be equal to CDI. For symmetry, we have AID equals to CDI. Then we can calculate them both in this 5-sided polygon IABCD. As AID CDI, their sum will be the sum of interior angles of a 5-sided polygon, which is 540, minus angle A, B, and C, which of them is 140. Then we divided this by 2. We will find AID as well as the CDI. So this is 540 minus 420. The answer is 16 degrees. So 20, 60, and the sum will be 140. The question we need to know the angle GID will be 140 minus 60 minus 20. Then will be 60 degrees. And the question is solved. So for the angle calculations in a regular polygon, it is always very important to calculate each angle of this regular polygon. And the use of isosceles triangles and symmetries sometimes will also be important. Okay, that's end for today for angle calculations. See you tomorrow. Keep fighting.